This is CS1101 lecture 3.2. Today we're going to be going over decision statements and logical operators. But first, let's take a quick look back at the receipt class that we made in the previous lecture. So one of the functions which we left in the main method in our implementation was getting the actual appetizer, meal, and appetizer, entree, and dessert cost from the user. So we could have made individual methods to get the appetizer cost from the user, and that would look something like this most likely. First, our method is a public static, and the return type will be double because we are going to be getting the appetizer cost, and the cost is going to be a type double. We have the name, which is getAppCost, and we have no parameters because we don't need to pass anything into it. So our first statement in this method creates a scanner object, and we're calling it keyboard, and we will use this keyboard scanner to get the double that the user types in. So we use a print line statement to request that the user enter the appetizer cost. The user will type it in, press enter, and then our next statement is going to return the double which the user typed in. That will be assigned to the variable app cost. And then our return statement will return the value which is stored in the variable app cost. But there's a major warning that you need to be aware of when you are attempting to do something of this nature where you want to use a scanner inside of a method. A better version of this method would declare a scanner in the main and pass the scanner object in as a parameter to the getAppCost method. So there are some compilers that will not allow you to declare multiple scanners. And an example of this is actually our Zybooks environment. If you declare multiple scanners, the Zybooks compiler will crash. So don't do this. Don't declare a scanner inside of a method. Always declare scanners in the main. So a better way of going about this is declaring the scanner in the main method and passing the scanner in as a parameter to any method that subsequently needs to be able to get input from the user. This is how you must code when working with scanners and methods in this class, specifically in the Zybooks environment. And all our assignments will be submitted to Zybooks, so it's important that you follow these instructions. Do not declare multiple scanners. Don't declare scanners in any other method than the main. Always pass the scanner from that point into any method that needs to get input from the user. So what this looks like, in the main, we declare the scanner object, and we give the name keyboard, and then when we declare our method which is going to get input from the user, we keep the heading the same as it was in the previous slide. However, now we include a parameter. So in the declaration we're saying we are going to pass a scanner. So scanner is actually a data type, so we're going to pass a scanner called keyboard, and then inside of our method we can use that scanner just as we would otherwise. Then when we use this method in our main, what we do is we call getAppCost, and as always we're going to have to capture the return value in a variable, but we are going to pass the keyboard into the getAppCost method. So this way there's only one scanner that exists, and we are able to make use of that scanner in methods without having to declare multiple scanners that look at the input stream. Now let's move to talking about decisions. So every programming language contains some way to choose execution paths inside of the code. So usually they're referred to as flow control. So you basically think of it like this. If your program is executing, then there'll be some situation in which, given a certain set of circumstances, perhaps we need to go over here, or given a separate set of circumstances, perhaps the right is the correct direction. So how do we choose? Well, there'll be some sort of decision statement that, based on a test, the program will continue along either the left or right path. That's why it's called flow control. It's changing the flow of the code. It's changing the flow of the program. So in Java, the way that we make a decision statement to choose the direction of the flow of the program, we will use if-else statements. Now, you're going to use these constantly. If-else statements are one of the basic units of a program. And if you think about it, really, a lot of decisions throughout your day boil down to basically if-else statements. If you stay up all night, you're tired, you're probably going to need more caffeine, so purchase a jumbo high-octane coffee. Else, well, you're probably still going to purchase a regular-sized coffee if you're a coffee drinker. So, if-else is something that mirrors our experience in everyday life. So on the right here, we have a standard flowchart diagram. In flowchart diagrams, diamonds represent decisions. Blocks, such as this rectangle, represent actions. So in this flowchart we have here, what is being shown is we come into a diamond, and the diamond contains a test. And the question is the test true? If the test is true, then we will go with the yes path. If the test is not true, we go with the no path. And this is, again, a good illustration of why it's called flow control. So the diamond here represents a decision statement. So let's look at that in code. This is the way we would code exactly what we see on the right-hand side in the flowchart. If, this is an if statement, if this test is true, so if it evaluates to a Boolean value of true, then we will do whatever is enclosed inside of the curly braces here. We will execute all the statements inside of the curly braces following the if statement. However, if this test is false, if it results in a false Boolean value, then we will execute the statements in the else statement. As an example, imagine that we get an input from a user, and this input is supposed to be their GPA. So if the GPA of this user is greater than or equal to 3.75, we will print "Welcome to Vanderbilt University." If their GPA is less than 3.75, we will print "Have you considered another college?" So this is the logical test. So our syntax above says in an if statement, we will have if, and then in the parentheses, a logical test. So we have if, and then in parentheses here, we have a logical test. And even though it involves a double variable and a double literal, this will yield a Boolean value. If GPA is greater than or equal to 3.75, this expression will evaluate to true. And if the GPA is less than 3.75, this will evaluate to false. So this will yield a Boolean value. If that Boolean value is true, then the statements inside of the curly braces following the if statement will be executed. If for any reason this test yields a false Boolean value, then the else statement will, all the statements included in the curly braces following the else statement will be executed. Now there are variations of the if-else. So actually we can leave the else off altogether. So perhaps we want to do something only in the situation where the test is true, and in the situation where the test is false, we do nothing. So on the right hand side, we have this shown in a flowchart. So we have our test, and if the test is true, then we do something, and then we move on with the rest of the statements in the program. However, if the test is false, then we do nothing and move on with the rest of the program. So in code, the syntax for this is just as before, an if statement with the test, the logical test, which will yield a Boolean value in parentheses, and then all the statements which are to be executed if the test is true in curly braces following the if statement. So now looking at an example of this, we again have the GPA situation. However, our logical test is now, if the GPA is greater than or equal to 3.75, it will yield, welcome to Vanderbilt University, please don't embarrass us if we accept you. And there's no else. So if, in the case where the GPA was lower than 3.75, we would do nothing. Why do we have these variations in if statements? Why is it we can do an if or an if else, or we're going to talk about an else if addition to that? Why do we have these variations? Well, it all comes down to style. It would look bad, it would just not read well if in every situation where we wanted to make something conditional. So perhaps we have the situation where if we're hungry, we will eat lunch. But on the other hand, there's no need for an else, because there's not something that depends on whether or not I'm not hungry, right? It only depends on if I am hungry. So if I'm hungry, I will eat lunch. However, the else in this situation is I'll do nothing. So rather than having this sort of a setup where we have if test condition and then else, yeah, we don't really do anything in the else, that would just be cumbersome. So rather than that, Java has extensions to the if statement so that we can have if and not actually have to use an else statement. So use the if statement variant, which is most appropriate for the situation. So in the interest of full disclosure and you being able to read Java programs written by others, you should know that you don't have to have curly braces following the if statement surrounding this, what you want to happen in the case where the test is true, if there is only one statement to be executed. So an example of this would be if, and then we have some variable here, balance. If balance is greater than or equal to 0, so this is a logical test that will yield either a Boolean value of true or false. So if this test is true, then we are going to execute this statement. So we don't have to have the curly braces, which in the previous slide followed the if statement. We can leave the curly braces off since there's only one statement to be executed in the case where the if statement is true. The same thing is also true for the else statement. So if there's only one statement to be executed in the situation where the test is false, then we do not need the curly braces. However, in this class, you are to always use curly braces when coding if statements and if else statements. The reason is because it is much more readable. Even though this code in yellow is valid and will not produce any compiler errors and will run, it is less readable than code which uses curly braces, because standard code is easily recognizable and readable. So again, styles are different in other classes, environments, and companies, but in this class, always use curly braces when coding if statements. So as I've mentioned, the test in an if statement is actually a Boolean expression. So we have seen several types of expressions, and this is yet again another type of expression. This is a Boolean expression that will evaluate to a Boolean value. So we have seen expressions that evaluate to double value. We've seen integer value expressions. This is a Boolean value expression, an expression which is going to evaluate to a Boolean value. Boolean values are either true or false. It's the only two possible values. We're also going to use something similar to this sort of a test, a Boolean test expression in loops when we get to that. These Boolean expressions are comprised of relational operators. So in general, we're going to be comparing two things to each other and testing for a specific relationship. And if that relationship is true, then we yield a Boolean value of true. If it's false, we yield a Boolean value of false. It's one or the other. It's never in between, and it's always one or the other. So these are the valid relational operators in Java. So a double equal sign means that two things are equal. So if you were to try to do a logical test using a single equal sign, your compiler is going to throw an error. Double equal sign tests whether or not the operand on the left is equivalent to the operand on the right. And operands may be expressions themselves. So in this example, we could do 1 plus 1 is equal to 2. The left expression will be evaluated and evaluate to a value of 2. The right expression is an integer literal of value 2. So yes, these two are equal, and this will yield a Boolean value of true. If you want to test the opposite, so if you want to test whether or not something is not equal, then we can use the exclamation mark equals. So often exclamation mark in programming languages represents the not operator. So this is not equal. So as an example, 3.2, this is a logical test. We are asking the question, is 3.2 not equal to 2.5? Now notice how I worded that. Is 3.2 not equal to 2.5? And the answer is yes. 3.2 is not equal to 2.5, and therefore this test would evaluate to a Boolean value of true. So others that you should feel pretty comfortable with: less than, greater than, or equal to, and less than or equal to, and greater than or equal to. And they work as you would expect. There are special logical operators which are used to combine multiple Boolean values. So the first that you should be aware of is the AND operator. So this would be two ampersand signs, and the way that this is used is to perform a logical AND between two Boolean values. So as an example, we have the test 2 is equal to 3. This is going to yield a value of false. Then we have the logical test, is -1 less than 5? The answer there is true. Now we're going to perform a logical AND. So when you are ANDing two things together, they both must be true for the result of the AND operation to be true. If you are less familiar with the AND operation, in the bottom left, see the table that shows the result of AND operations for logical tests. So given two operands P and Q, if P is true and Q is true, then P and Q is also true. However, if there is any false value involved in the operation, so if Q is false, then P and Q is false. If P is false, even though Q is true, P and Q is false. And if they're both false, then P and Q is false as well. So in the situation back in this example, we have false and true. So from our table, false and true is going to yield an ANDed value of false. And that's exactly what we got. The table on the bottom left is known as a truth table. So we have listed the possible states of all the operands. So this is every possible combination of P and Q Boolean values. And to the right, we have listed the result given an AND operation for each of those combinations of P and Q Boolean values. Next, we have the OR operator. So it's easier for me to understand the OR operator than it was for me to initially understand the AND operator. So OR should be understood to mean if this test is true or the other test is true, then we will have a value of true. So consider P and Q again. If P is true or Q is true, then P or Q should be true. So obviously P is true and Q is true, therefore P or Q is true. P is true, however Q is false. But remember what we said, if P is true or if Q is true, then P or Q is going to have a value of true. If P is false, but Q is true, well then we said if P or if Q is true, P or Q is true. So this would also yield a value of true. The only situation in which you'll have a value of false is in the situation in which P is false and Q is false. So here, P or Q would also result in false because neither P or Q is true. So the result of ORing these two together, which is how we would refer to this, we would say that these were being ORed together. These were being ANDed together. So we know that the left operand is going to evaluate to a Boolean value of false. The right operand is going to evaluate to a Boolean value of true. So we are ORing these together. So if the left operand is true, it's not, or the right operand is true, it is, then the ORed value is true. So we would wind up with a value of true given an OR operation on these two operands. And then we have the NOT operator. So I said that often in programming languages, the exclamation point is used as a NOT operator. And that's exactly what's happening here. So given some Boolean expression, we want to invert the result. So if the result were true, we want to invert it to false. And if the result were false, we want to invert it to true. We can draw the truth table for this, and it's drawn in the lower right. So in the situation where P is true, not P is false. In the situation where P is false, not P is true. So we're just inverting it. So our Boolean expression 2 is equal to 3 yields a value of false. However, we are going to now apply the NOT operator, which will invert the false Boolean value and make it a true result. So we have introduced multiple operators used to test and obtain a Boolean value, but there's one caveat that we need to mention. If you're testing for equality between two strings, it's better not to use the equals equals operator. Though in some situations it may work, depending on how you declare your strings, it may not. So even though two strings contain precisely the same sequence of characters, the equals equals operator may return false. So to avoid this, it is best to use the dot equals operator, which is included in the strings class. So in a programming language, the primitives are considered those types which are necessary to be able to make a programming language work, and all other types and classes should be able to be built from those primitive classes, or from those primitive types. So strings are not a primitive type. They are a class which has been implemented using primitive types, and therefore comparing them is best done using their built-in class comparison method. So now let's look at a concrete example of how to use the dot equals operator to compare two strings. So we're going to get the operator's name, the user's name, and we're going to compare it to see if that name is Billy Ray. And if it is Billy Ray, we're going to print out, did you spend a lot of money on your brand new guitar? So we first declare our scanner. So we must be in the main, right? Because we're declaring a scanner. So we declare a scanner called console, and then we use a print line statement to ask what is your name. Then we have declared a variable which is of string type, and the variable is called name, and we are assigning it the value which is returned by the next line method of the console, which is a scanner. So the user types something in, presses enter, next line grabs what they typed in, and packages it as a string, and returns the value to be stored in the variable name. Now, we have an if statement, and inside the if statement, parentheses, we have an expression that is supposed to evaluate to a Boolean value. If this doesn't evaluate to a Boolean value, then the compiler will throw an error. So we will say the variable we want to compare to, which is string called name. So we want to compare the contents of our name string to the string Billy Ray. So understand here what's happening is equals is a method which is a part of the string class, and our variable name is actually an instance of the string class. So in this line, what we're doing is accessing the string object called name, and we're using the dot operator to access the equals method, which compares the contents of the string object called name with the parameter that we pass, and we're passing the string Billy Ray. This is a string literal. We're passing it as the parameter to that comparison method. And this method will return a Boolean value. It'll return true if the content of our string object is precisely equal to whatever was passed to the equals method, and false otherwise. So if this returns true, then our Boolean expression will evaluate to true, and we will execute the statements in our curly braces following the if statement. So let's look at some use of logical operators and if statements and talk about what's good and bad about these. So the first situation we have here is a not so great combination of if statements. So the situation is we want to know if the value which is stored in X is between -10 and 10. So typically, you know, in standard math, this you would write this something like right. You've probably dealt with those sorts of statements in math classes. In Java, we can't directly code this into a test without using conjunction operators like and we'll discuss that in just a second. That is a better way to go about this. So someone thought, well, what I'll do is I'll write an if statement, and if the value stored in X is greater than -10, that's sort of passing the first test, right? And then if the value stored in x is less than 10, well, that's passing the second test. So they sort of just split this into two individual tests and said, well, it should pass both tests. And if it does pass both tests, then we will print out x is 1 digit long. However, a better way of going about this, because what's really happening is you have two tests and you want to know if both of the tests are true, a better way of going about this is to use the AND operator. So we can say if x is greater than negative 10 and x is less than negative 10, x is 1 digit long. Now some of you may be thinking, didn't we talk about checking to see how many digits something had using the mod operator? Yeah, you could do that as well. You could say if x mod 10 is equal to x, then it is also 1 digit long. I won't explain this. Think this through. This would be a good exercise for you to take apart and understand why x mod 10 being equal to x itself would suggest that x is only 1 digit long. But a better version of this logical test would be not to split it into separate ifs, but rather to use the AND operator. The reason is because this is actually what you intended to accomplish. You were just sort of hacking it together by using multiple if statements. So this is communicating what you intended to accomplish more directly. So we've introduced several operators, including the operators that we started with in the beginning of the class. So here is a list of operators and their precedence so that we don't get lost in the weeds. So remember, parentheses still sits at the pinnacle. Parentheses still rule. They are the first and highest precedence. But beyond parentheses, we have the unary operators. They take precedence. So this operates to make a digit positive, make a digit negative, increment, decrement, and then the not operator. So these are the highest precedence operators that we have. The next highest would be the binary arithmetic operator. So if you remember, unary operators are those which only require a single operand, while binary operators are those which require two operands. So we have multiplication, division, and modulo. Next we have binary arithmetic operators for plus and minus. Then we start getting into the Boolean operators. So at this point we have our comparison operators, less than, greater than, less than or equal to, greater than or equal to. Then we have more Boolean operators, is equal, is not equal. Then the next are operators that you probably won't use very often, but a single ampersand is to be read bitwise and a single bar is to be read as bitwise or. We're not going to talk about these at this point, but understand where they fall in the order of precedence. You can find more about these in the book. If we need to discuss them, we'll discuss them at a later date. These are to be read as logical and logical or. So a single ampersand is a bitwise and, while two ampersands together is a logical and. The same thing is true of the or. Single bar, as I said, is a bitwise or. Two bars together is a logical or. You will predominantly use logical and logical or. To ensure understanding, let's take a moment and place parentheses in this expression so that it will evaluate just as it does without any parentheses. So to do this, we have to identify the highest precedence operators involved. So the highest precedence operator, there's no parentheses, right? The next highest precedence operators would be unary operators, so not or unary plus or unary minus, but we don't have any of these either. So then we have our binary arithmetic operators. So we have a binary arithmetic operator, division, and we have binary arithmetic subtraction. So the highest precedence is the division. So we would place parentheses around the expression min divided by 2. The next highest precedence would be the subtraction. So we will parenthesize this expression. And the next highest precedence operator we have would be the comparison operators. And when we have multiple operators of equal precedence, we work from left to right. So this would be the next expression of highest precedence. Now we have another comparison operator as the highest precedence. And finally, we have the logical OR operator combining both expressions. So it should have been clear from the list of precedents and operators and from our example previously, but relational operators always have lower precedence than arithmetic operators. So any arithmetic left to be completed must be completed before relational operators will have precedence to perform their evaluations. So we would, in this particular situation, we would evaluate first the parenthesized portion, because parentheses always take precedence. So this would result in 6. Then we have multiplication operators, which would be of equal precedence, but we work left to right. So 35, and then 30. Then we have addition is the next highest operator, because, as I said, arithmetic operators always take precedence over logical relational operators. So we now have 35 is greater than or equal to 33, at which point the next highest precedence operator is the relational operator, and this will evaluate to a Boolean value of either true or false. In this case, it evaluates to true. I mentioned this previously, but you cannot chain relational operators. So a statement such as this will produce a syntax error. Rather, you would need to split this into two expressions combined by an and, a logical and. So even though what we're attempting to do here is find out if x is between 90 and 100, the way that we would need to go about that is to split that into two tests, as we did previously, a test for if x is greater than or equal to 90, and a test for if x is less than or equal to 100. So in the following if statement, we have one expression for x greater than or equal to 90, which will yield, which will evaluate to a Boolean value of true or false. And then we have a second Boolean expression, which will test to see if x is less than or equal to 100. And then we will combine the result of these two Boolean expressions into a single Boolean expression using the logical AND operator. So if x is both greater than or equal to 90, and x is less than or equal to 100, then the system will print out great score. Now you may realize that the parentheses around x is greater than or equal to 90 and x is less than or equal to 100 were actually not necessary. The precedence of the operators would have made this evaluate correctly anyway. While that is true, parentheses make code more readable, and it is more likely that someone will understand how to read a statement parenthesized than it is that they will be able to read it simply based on the operator precedence. At this point, pause the video and do this mini exercise to check and see that you understand how Boolean expressions will evaluate. Use the values set for the variables x, y, and z here. So obviously 10 is less than or equal to 5 would be false. Y is less than 10, so in this case y is 5, so 5 is less than 10 would be true, and 5 is less than or equal to 12 would be true, so these two ANDed together would also be true. In the following example, the highest priority operator is the division, the arithmetic division. So we have x divided by y, x being 10, y being 5. This is going to evaluate to 2. Then we have another arithmetic operator in the plus. So that's a binary plus. So x is 10, 2 plus 10 is going to be 12. So we'll just put 12 and mark that out. The next highest priority operator is going to be the relational greater than. So z has the value 12, z is greater than, or 12 is greater than 20. This will take on the value false. Now we would look at the relational operator equals equals. So 12 is equal to z, z is 12, so this would take on the value true. Now we have true and false. True and false is going to have a value of false. And that's what we got. I'll leave these for you to work through as exercises for the student. So there's something to keep in mind whenever you're using variables inside of if statements. If you declare a variable inside of an if statement, that variable is born and will die with the curly braces around the if statement. So let's say, for instance, that this code is used. If sales is greater than this class constant big month, then we declare a variable called commission, which is an integer, and we assign it the value 500. Then later on down here, we will print out commission equals, and we will concatenate the value commission. Seems fine. No. Because this variable commission was declared inside of the if statement, then when the if statement terminates at this second curly brace, the variable commission is removed from memory. So it doesn't exist outside of the scope of this if block. There's actually a further problem as well. So the variable commission is used in the else, but there's a possibility in which sales is less than big month. So in this case, commission has never been declared because we were going to declare it inside of the if statement. So this doesn't work. We would have to declare this variable separately, int commission, to be able to make use of it here. However, the same issue is going to occur. This variable commission, if we declare it inside of this curly brace block, then it will only exist in the scope of this curly brace block, and as soon as the second curly brace is encountered, the variable commission would again be deleted from memory. So if we were going to make use of this variable commission in the way that we see here in this program, the way that the programmer intended to use it, we would have to declare the variable somewhere above, right? We would have to have our declaration somewhere up here. So here would be a more proper way of going about the code we saw from the previous slide. Now we are declaring the commission variable in the method scope so that we don't have the issue of declaring inside the if statement and therefore only existing within the if scope. So now the variable commission is available for use inside of both the if, the else, and in our print line statement. So this is dealing with the scope of the variable. So this is a situation where the professor wants to automatically print out some sort of an appraisal or feedback to students based on their grade. But it seems that they may have made a logical error. So what happens in the case where you receive an 80 on the exam? So this is presumably inside of our main function. So we have declared a scanner. We ask the user what is your current course average, and they type it into the console and push enter. The console.nextInt method gets their input and packages it as an integer and returns that value to be stored in the percent variable. Percent is an integer. So let's say that percent, the variable percent, has the value 80. So is percent greater than or equal to 88? No. So we will not execute the code in the curly braces following the if statement. If percent is greater than or equal to 78. Yes, 80 is greater than or equal to 78. So then we will do the code inside of the curly braces following the if statement. So we print out, you're doing good. Then we move on to the next if statement. Percent is greater than or equal to 65. That's true as well. So we're going to print out, you're doing okay. I think you're starting to see the pattern. Oh no, we're going to check this if statement now. Percent greater than or equal to 54? Yes, it is. You're not quite there. And then else, chat with your professor. So we're only going to chat with the professor if the grade is less than 54. Now, the issue is here that these if statements are not related. They're individual. So we're going to check if the grade is greater than 88, if it's greater than 78, or equal to, if it's greater than or equal to 65, if it's greater than or equal to 54, and then the else is only connected with the previous if. So else's want to glob onto if statements. So an else is going to associate itself with the most recent if statement. So the issue here is what the programmer intended to happen was for only one of these statements to get printed out. However, the way that it is coded, it will print out, you're doing good, you're doing okay, you're not quite there. They won't print out chat with your professor for a grade of 80, however, though. So that they did get that somewhat correct. Based off what we've talked about so far, using just if-else, what we might do to solve this problem is say, if the percent is greater than or equal to 90, then print out you got an A, or you're doing great, whatever we want to print out based on that grade, and then include an else. And inside that else, if the person did not have a percent greater than or equal to 90, we will now check to see if they had a grade which was greater than or equal to 80. And then we'll print something based on that. And if that's not the case, we'll check for greater than or equal to 70, print something. And if that's not the case, we'll check greater than or equal to 60. And if that's not the case, then there's only one possible grade left to give, and that's an F. This will work. This is a nested if statement. But there's a better way to do this that is much more readable and less clumsy. This is referred to as the if-else if. So we have our standard if statement that we have looked at multiple times now. We have the if followed by a Boolean expression, which will be our test. And if that Boolean expression evaluates to true, then we'll execute the statements in the curly braces following the if statement. And we know what the else is. We have encountered that before as well. But now we're introducing this new type of object called the else if. An else if provides mutual exclusivity. So in the last slide we saw where we tested for one particular situation and then we followed it up with another if statement. But those were independent. We would test each of the ifs regardless of if a prior test had already passed. So we use the else if as a way to introduce mutual exclusivity. So these are not independent. The only way that the else if will be tested is if the test following the if statement failed. So we first test the if statement to see if it is true. If it is, then we will execute the statements inside of the curly braces following the if statement, and then our program pointer will jump to the next statement outside of this if-else if statement. However, if the test in the initial if statement is false, then it will continue to the else if statement. and it will evaluate the test in the next else if statement. And it will continue to do this, and you can chain many else if statements together, and then you can terminate with an else, which is the guaranteed result given that all other tests have failed. So an example of this would be, if a number is greater than 0, print number is positive. So if this is the case, after executing all the statements in the curly braces and it encounters the terminating curly brace, the program pointer will jump to the end and continue from this point on. However, if the logical test in the parentheses is false, then the program will continue at the following else if statement. It will check to see if the number is less than or equal to 0, in which case it will print this number is negative. If that were true, if that test is true, then after executing all the statements in this set of curly braces following the else if statement, the program pointer will jump to the statement following the if block, just as it did previously in the case of the if being true. However, if both of these tests prove false, then we will execute whatever is inside the curly braces following the else statement. So this is a way of introducing, as I said, mutual exclusivity. Only one of these results is going to occur. So consider this situation. If we do not terminate a sequence of if-else-if statements with an else, then there is technically a program path which doesn't execute any of the options. So in this particular example where we have if, else if, what happens if this test, and this test all prove false? Well, the program pointer, the program will execute none of the statements and will continue having executed none of them. However, if we were to add an else statement, then we would have a guarantee that one of our program paths in this if, else would be executed. There are situations where we need to make sure that one of the paths we intend is executed. We don't want to leave any available. So just depending on what you intend to occur, you need to pay attention to whether or not you need to include an else in a system of mutually exclusive if statements. As a final example, in the case of the example here, if place is equal to 1, we will print you win the gold medal. However, if place is equal to 2, we will print you win a silver medal. But if place is equal to 3, we'll print you earned a bronze medal. How would we modify this program so that no matter which place you placed in, other than the top 3, there would be a message for you? So if someone placed in the 44th position or the 153rd position, a message was still printed out. How would we go about that to ensure that there was a message printed regardless of your position? The easy way would be to add an else statement. So we have specific messages for places 1, 2, and 3, but then we could have a generic message which would be printed in the situation where none of those tests were true.